Okay, welcome to part 2 of the slope lesson. So we ended up developing the formula last day for slope is y2 minus y1 over x2 minus x1, rise over run. I'm going to use that formula to calculate all of these slopes algebraically without graphing them, which is how we figured it out last time. Okay, so what you do is, if you've got to find the slope of AB and you know point A and you know point B, 2 points, what you do is you identify, and I recommend you do this, this could be point 1, so that would be x1, and this would be y1. And then the other point would be x2, y2. The order doesn't matter, so why not just work in the order that it's been given in. Okay, we know slope in our formula is y2 minus y1 over x2 minus x1. So we just have to plug these two values in. y2 is 3. And I have to subtract y1, which is 1. And that is over x2, which is negative 4, subtract x1, which is 2. And so I'm going to get 2 over minus 6 or minus 1 over 3. That is the slope of that line joining those 2 points. And we could always just draw a quick sketch to see if it makes sense. If we were at a point of 2 over and 1 up, that's approximately there. And my other point would be negative 4 and 3. I just have to know like it's higher than the other point. And then I can see that that line has a positive slope. Oh, I'm messing up. Sorry, it's late. I should have quit. Okay. This has a negative slope because it falls from left to right. And we have a negative slope, so we probably did it right. Okay, next one, slope of CD. You should turn the video off and go do all these calculations and then turn the video back on to see if you got it right. Notice I'm going to label all of the points that they give me as x1, y1, x2, y2, and I recommend you do the same, and I recommend you draw a little sketch of the points. So, for example, in this one, I would go negative 5 and 3 and negative 2 and 4 and draw a little sketch just to get a sense of what's going on. So I can see that this slope should be positively sloped. So when I calculate it, I can catch my error if I subtract in the wrong way or something. Okay, turn the video off and do all the questions up to D and then check back. Okay, so hopefully you've done all of these. So I'm going to do them quickly. We're using this formula. y2 is a 4, y1 we're going to subtract as 3. On the bottom we've got minus 2, and here you want to use brackets, minus 5. And so we get 1 over negative 2 minus 5 is the same as negative 2 plus 5, and that's 3. So we get a slope of 1 over 3, which makes sense, it's positive. Next one here, slope of EF, y2 is 1. Subtract 1 over 5, subtract 2, we get 0 over 3. Hey, that's 0. Let's see if that makes sense. If we remember, this line should be horizontal if its slope is 0. So let's check. Point E is at 2, 1, and point F is at 5, 1. Oh, that makes sense. That's a horizontal line. Horizontal. If you had have noticed that the y's were the exact same at the beginning, you would have recognized, hey, both those points are the same height. They're both at a height of 1, and so it's going to be a horizontal line, and I know that slope is 0. If you don't notice it, you calculate and you'll figure it out. The next one, negative 5, 2 and negative 5, 7. Hey, I said negative 5 twice. That's the x-coordinate. Negative 5, 2 and negative 5, 7. Hey, that's a vertical line. That should be an undefined slope. Let's check. 7 is my y value. Subtract y1 is 2, and then I got negative 5 minus 5. So I get 5 over negative 5 plus 5 is 0. Undefined, which is what we were expecting. So drawing a sketch will help you, just to catch errors, or at least make sure you feel confident that you're getting the right answer. Okay, this one is a little bit of a tricky one because it asks you to use a given point and the slope to find another point on the line. So that's not that hard to do graphically. It's a lot harder to do algebraically. So let's start with the endpoint 3,5. So I've already drawn a grid on here. 1, 2, 3, 1, 2, 3, 4, 5. Okay, so there's my point A. And I have to have a slope of -5 over 4. Well, I know that that is a rise. And I know that is a run. Rise over run. That's what slope is. So from this point that I know, I could simply rise -5, which means go down 5. 1, 2, 3, 4, 5. And I could run 4. 1, 2, 3, 4. And I would end up at this coordinate point, which is, I think it's 5, 0. Oh no, can't be 5, 0. Oh, I started at 3 over, right? 7. 1, 2, 3, 4, 5, 6, 7. Oh, excuse me. I think I'm going to need some water. Okay, so that gets me to another point, and its coordinate points are 7 over 0 up. I could also go continue on with the same pattern. If I know the slope is -5, 4, I could keep going because I know the slope is constant for the whole line. It doesn't change. I could go down another 5, 1, 2, 3, 4, 5, and over another 4, 1, 2, 3, 4. And I would get the point 8, 9, 10. That's 11. Is it? That is at 11. And I'm at -5, it should be. Okay. I could also, from this point, go the other direction. I could rise 5, 1, 2, 3, 4, 5, and run 4 in the negative direction. Because if I have to, I could put that negative on the bottom number instead, and I could go up 5, 1, 2, 3, 4, 5, and I could go 1, 2, 3, 4. And that brings me to the point -1. And where was I at? I was at a height of 5, and I went up 5 more, so I'm at a height of 10. Sorry, I didn't use the best graph paper for this. Okay, so that's how you can find several other points graphically. You just start at the point you know and count, rise, and run in either direction to get other points on the line. Algebraically is much, much harder. Oh, sorry, I should note, you could keep going. I could keep going 5 down, 4 over, 5 down, 4 over, or in this direction, I could keep going 5 up, 4 to the left, 5 up, 4 to the left, and I could continue that and keep finding lots of points. And in fact, I could find an infinite number of points because that's how many points there are. It never ends. Algebraically, you really can't do this because there are so many answers. You know that slope is equal to y2 minus y1 over x2 minus x1. Well, we know that this could be x1 and y1, let's say. And we know the slope. So if we know those two things, we could say, well, I know the slope is, in my formula here, is -5 over 4. And I don't know a second point, but I do know these points. So I'm going to say my second point, I'm just going to call it y2, well, minus 5, and x2 minus 3. So I don't know what those points are. I could cross multiply. -5 times x2 minus 3 equals 4 times y2 minus 5, and distribute. And I'm just going to group the numbers over here. Okay, I basically now have an equation that describes how x and y are related. There are many answers. I couldn't find them all, but I could try to find some of them. It's easier for me to find values of y and solve for x because I can see that this is 5 times a number I'd like my answer to be divisible by 5, and 35 is divisible 5. So when I add it to something, I know that it would be nice if this number was divisible by 5. It's just going to make it easier. So I'm going to use the first value I'm going to test is y being 0. Actually, I did it already, so I'm just going to show you what I did. Sorry, this video is getting crappy. Okay. Oh, there we go. So I could let y be 0 and plug it in. So 4 times 0 is 0. And then I could, solve it, and I would get x is 7. So I know the point 7, 0 would be on my line. And it is. We already found that one. I could also let y be 10. And if I did that and I plugged in y is 10 and I solved it, I would get x is negative 1, negative 1, 10. I also got that point. I can kind of see what numbers to try. If I tried another number, such as, let's say I tried x being 1, I would get a value that isn't very nice. It would be between the points. It would still be true, but it just wouldn't be a nice one. So I just happened to pick values that I knew worked to show you that, you could come up with a bunch of points. But this would take a long time and a lot of guessing work. So it's not ideal when you don't know what those 2 points could be. But you can see we could come up with a huge list of points. It's infinite. So ideally, you would do that one graphically. Okay, on to the next page. That was a pretty tricky question. Okay, so now we're on to graphing given slope and a point. So if you have to graph given slope and a point, what you do first is plot the point. So we know we're looking for a line that passes through the point, -1, -2. So we go to -1, -2, and there's our point. And now we know our slope is -2 over 3. Well, we have to attach that negative to one of the values. So I'm going to write -2 over 3 and recognize that this is my rise and this is my run. So from this point, I'm going to rise -2. So I'm going to go down 2, and I'm going to run in the positive direction 3. 1, 2, 3. And I'm going to land there. And then I connect the points. And that would be line A. I go on. You should do the same. Go on to the other points. Turn the video off. Plot the point. See if you can do... Oh, actually, turn the video off after this one. You're going to plot the point -2, 1. -2, 1. Plot that point. And the slope is 3. Well, we need to rise over run. But I know the number 3 could be written as 3 over 1. And now I can see that my rise is 3 while my run is 1. And then I can do it. So from here, I'm going to rise 3, 1, 2, 3, and run 1. Plot another point, connect the 2 points, and I've got my line B. Okay, you continue with C, D, and E on your own, and then come back and check with the video. Okay, 4, 5, 4, and 5. Well, 4, 5 is way up there, which was a little tricky because my slope is 3 over 4, and I can't rise 3 and run 4. So what I could do instead, in order to come down this direction, is I could change that to -3 over -4, because that's the same as 3 over 4. And then that allows me to come down 1, 2, 3, and over 1, 2, 3, 4, and draw the line. And now if we check from here to here, rise 1, 2, 3 over positive 1, 2, 3, 4. Okay, so that one was a tricky one. D, -5, -4. -5, 2, 3, 4, -4. And it has an undefined slope. Well, I know if it's got an undefined slope, slope equals rise over run. And I know that to have an undefined slope, I would need a 0 in the denominator, which means I run 0. So if I pass through this point, -5, 4, I don't run either direction, but I can rise any number I want to create a line, and it's going to be a vertical line. Slope of 0 I know is going to be a horizontal line, but let's draw it. I know slope is equal to rise over run, and if slope is 0, there must be a 0 in the numerator, and this would be some number. So I'm going to plot 5, 3, 5, 3, plot a point, and I know I'm going to rise 0, but I'm going to run. Doesn't matter how far you run, that's your E. Okay, next one. Find one coordinate of a point when given the other coordinate, another point, and the slope. So we've been given point A is negative 3, 1. Point B is 2k. We don't know that coordinate point for point B, but we do know the slope, and we're asked to find k. So identify it x1, y1, x2, y2, and slope. And you know slope is equal to y2 minus y1 over x2 minus x1. You know that is a relationship that relates 2 points and a slope. And that's what we've got here, 2 points and a slope. Well, notice there are 5 variables there. And if you have an equation with 5 variables, you need to know 4 of them. If you know 4 of them, this is what I've written here. If you have 5 variables, you need to know 4 of those variables to determine the 5th unknown. So the 5th one is the one you don't know. So just take these values and plug them into this equation. Slope is 4 over 5. K is my y2. And y1 is 1. And x2 was 2. And x1 was minus 3. Okay, so we get 4 over 5 equals k minus 1 over 2 plus 3. They're both over 5. I could multiply both sides by 5, and it would eliminate those denominators. So 4 would equal k minus 1. And then I could move the 1 over by addition, and so I'd get k is equal to 5. Okay, we're going on number 6. Now, I've already talked about this, but I just want to write it down. Why all horizontal lines have a slope of 0. To move from one point on a horizontal line to any other point on a horizontal line, you will always have a 0 rise, and yet you will run some number. Okay, you're going to run somewhere to get there. So the slope is always equal to 0 over run, and that's equal to 0. Similarly, vertical lines, when you go from any point on a vertical line to another point on a vertical line, your run is always 0. But you do have a rise. It's some number. And since slope is equal to rise over run, our rise is some number, and we put it over 0. And that is undefined. That's a way you could explain it. Number 8. A ramp rises 2 meters over a run of 5 meters. So it's going to rise 2 meters when you run 5 meters. If you want to make this steeper, the way you would change this is you could make, just lean this up higher. Well, if you made that go higher, imagine fixing it here. That's where you got to start. If you want to make it steeper, you would push that up higher, which means you're going to make the rise higher. Make rise bigger. Make rise bigger. Similarly, you could keep the rise at the number 2, keep that, and you could bring the bottom of imagine a ladder, you could bring the bottom in closer. And so you could also make run smaller. To do the opposite, I've just said both. I've answered both questions, A and B. So A is you could make it steeper by making the rise bigger, and you could affect the run by making the run smaller. You would also make it steeper. Either way, that'll work. Okay, number 9. A steel beam goes between the tops of 2 buildings that are 7 meters apart. So I'm going to have a building. One building is 41 meters tall, the other is 52. So I know one's taller than the other. And I know the distance between them is 7 meters. And this one's 41, and this one's 52. And so I could say, well, 52 take away 41. This extra bit of height is 11 meters. It's 11 meters taller. So that allows me to then draw a line the slope of the beam that's going between one to the other. There's my beam. I know it's got a rise of 11 over a run of 7. Slope is equal to a rise of 11 over a run of 7. So that's the slope. Okay, now we're on to the homework, and the answers are at the end of the sheet. You can do these questions to practice what you've learned today.